So let me explain the exercise 1 first. The linked stack. To implement the transfer method in the linked stack class, I need to ensure that all the elements from the source S are moved to the target stack. The elements that is at the top of the source stack should be inserted at the bottom of the target stack, maintaining the reverse order of the elements. As a first step, the step should be as follows. We can pop the elements from source stack one by one, and then each element popped from the source stack should be pushed to the target stack. And then after transferring all the elements, the source stack should be empty. So here is how the transfer method can be implemented. First, transfer all the elements from the current stack to the target stack. And then this popped, removed and returned the top elements of the current stack, and target s.pushy element, which is add the elements to the target stack. The method continued this process until the source stack is empty. Let me move to the testing in the main method. To test this method, I created the source stack and a target stack, and then pushed the elements into the source stack. I called the transfer method to move elements from the source stack to the target stack, and then print both stacks to verify the elements are transferred correctly, and then source stack is empty. Let me show you the result. The result is as follows. And then I will explain the exercise 2. Before I move to the exercise 2, I'm going to explain the result, the output. Before the transfer, the source stack was contained lime and kiwi and apple. After transfer, the source stack is empty, and then target stack has the elements in the same order as they appeared in the source stack from bottom to top: apple, kiwi, and lime. This way, the transfer method correctly moved all the elements from the source stack to the target stack while maintaining the desired order. Now I'm going to move to the next exercise 2 and explain it. This following code is newly added to the linked GUI class to implement the concatenate method to test it. This method is will transfer all the elements from one queue, source queue, to another queue, target queue, and result in source queue being empty. The key point to this code is we will dequeue elements from source queue and enqueue them into target queue. Once all elements are transferred, source queue will be empty. Here is the method, concatenate method. Transfer all the method from this source queue to the target queue by repeatedly dequeuing from the source and enqueuing to the target. The source queue become empty after operation. Here is the main method. First, I created 2 queue, source queue and target queue, and add elements to both queue. and then call the concatenate method. Call the concatenate method to transfer elements from source queue to target queue. And then lastly, print the contents of the both queue before and after the concatenate. Here is the result. This code demonstrates the functionality of the concatenate method, transferring the elements from one queue to another and clearing the source queue in the process. Before concatenate the apple, kiwi, lime, the source queue contains the elements people, kiwi, lime. Target queue before concatenate is the orange and the banana. The target queue contains the orange and banana. After concatenate, the source queue is now empty because all of these elements have been transferred to the target queue. And here, the target queue now contains all the original elements of both the source queues and its own element. The order of the element is preserved with the apple, kiwi, and the lime added after the oranges and banana. That is all for the explanations for the exercise 2. Thank you.